So my name is Görkem. I work for a little but mighty company called Jozu. I'm the CTO of Jozu, and today we're gonna have a quick look at how the AI ML supply chains actually work today and how we can make it better. So this talk is gonna be a lot about me complaining. All right, so what you see on the screen is your typical ML workflow, ML ops workflow today. You curl into something, Hugging Face, an S3 bucket, Google Drive, something, and then you retrieve model bits, or you retrieve some unknown skills, or some MCP server. And then you take those model bits, you retrieve some, curl into Hugging Face again, you retrieve some data set, which you don't know. But trust me, Hugging Face has never been known to have any bad bits in it. And then you do your fine-tuning. You train your model, and then you deploy. It's easy. It works. And the sad thing about this is that's actually normal. Like, that's how it is done today. Most organizations have no idea where the data set that they have used for training come from, where, like, I have actually seen this. There was one model that they were deploying to production. This was an ML model. It was named after the guy who trained it. And nobody knew him on the group that I was talking to, so they weren't sure where it was coming from, but it was working, so. I couldn't figure out this yet. So the sad thing about all of this is we actually seen this before, right? This actually happened to us before. Remember 2014 when we were happily creating Docker images from Ubuntu latest? And you know, we had a very good run for like a decade with that. And then what happened? SolarWinds happened. When the SolarWinds happened, everyone started to realize that, hey, you know what? We cannot just say from Ubuntu. There was one, I don't know, many of you remember that. There was one Docker Hub account called Docker123 something. And it had 14 or 15 Docker images with the legitimate name. So it was, the account was Docker12345/Terraform. And that one actually had 5 million pulls, and all those images were compromised. So that's the point where the industry actually realized that, hey, you know, we can't actually do this. There is something called provenance and attestations and so on and so forth. Let's find a solution, a better workflow for it. What is our workflow today when we are doing microservices or software? Our workflow is we sign them, we attest to them, we verify them, and we gate them. Like we have tools like Cosign that does the signing, that does the attestation. We have, again, Cosign can do verification. OPA, Querno can do gating as well. So all of this tooling actually exists. But does it exist for agentic AI and ML? So this is like already happening on the agentic AI and ML, right? In the last 18 months only, there had been these incidents. For instance, there was one that was very recently published by SNCC. They looked at the Clo Hub and looked at the skills and realized that there was Their number was, when they published it, was 76 malicious skills. How easy is it to write a skill? It's a markdown file. How many of you used a skill? How many of you looked at what it is, what's inside it? You're the good ones. So another one is the MCP remote. I love that one because that one basically gave you a bogus OAuth endpoint, and with that it could do any remote code execution. There was another MCP server called Postman. Agents could use that MCP server to send mail. What it did is it actually BCC'd a copy to another address. And these things actually had enormous number of downloads. We don't know what the usage and what the impact is for most of them. So this is already happening. It just doesn't make the news with all the other AI news. And one thing that you may have noticed, the attack surface is not just the model. It's not just the MCP. It is not just the skill. It's everything. Everything that goes into your agentic workload is affected by the supply chain. So one thing that when we started thinking about this problem, and we actually started thinking about this problem earlier than everyone else, we noticed that, hey, those tools actually exist. You know, we do have OCI artifacts, which have give you access to Sigstore, Cosign. You can do verifications using Cosign, verify. The only thing that was missing at that point was to come up with a standard layout for the agentic AI artifacts. So we went to CNCF, created a project called Model Kits, GitOps, sorry. And as part of GitOps, there's a CLI and an SDK, but also a specification for the OCI artifact. So the layout of the OCI artifact is specified on a CNCF project. Actually, in 2 CNCF projects, because later on, there were a few more companies interested in this, Docker, Red Hat, ByteDance. So we formed a specification-only project called Model Pack, which is, if you look at it, they are pretty much the same specification with a few changes here and there. Like the way that the config is handled is different on model packs compared to model kits, but the rest is pretty much same. But if you go and use the kit CLI, it supports both because it's just a single if sentence that we needed to add. So the solution was actually very elegant. Like whether you have an MCP server or an agent skill or a model, you could use the same registry, same infrastructure for signing things, same enforcement, and you could get an end-to-end supply chain that is as secure as your existing software chain. So what did the workflow come to? The workflow becomes pack, sign, attest, and we'll talk about attest a little bit more, gate, and run. So that's the new workflow for your agentic AI. And with that, I'm going to switch to demo. Because it makes it real, right? I don't know if this is visible. OK, so in order for you not to watch me fat finger CLI commands, I have some scripts that I have written. They are they will look like I'm typing, and it is real typing. It's just scripted. So if you are wondering how I am able to type that fast with a single hand, because I'm not. So um, so I'm going to just run that script for you. What the script does is it actually types these things as I press one key. So nothing fancy. But the rest of the execution is real. One of the things that I did on the script was to make it more obvious. I actually used some environment variables so that you don't have this very long, hard to understand command lines. You can understand them better. So this is the actual values that I'm substituting. So you can, so that you have, you know what it is real. This is a demo about packaging a vision model, which we called creatively Northwind, because I'm from Canada. And it has what you may expect. There's a safe tensor there, so that's the trained model, and there's an eval set of JPEGs, some inference YAML for configuration, a Python file for inference, stuff that you can expect. The only thing that is unexpected here is the kit file. The kit file is the Docker file equivalent for GitOps. It basically tells where the artifacts are when it is doing the packaging. So, and also some metadata about, the model and so on and so forth. Most of this file is optional. You need one layer, which is either a model or a data set or a code or a doc or a prompt. Whatever you are packaging, you need one of those. You can have multiple, but you need at least one. The big difference between a model kit and a Docker image is a Docker image is an additive file system. So you cannot just unpack single layer. Model kits allow you to unpack a single layer. So I can actually say unpack content classifier -v3, which is the name of the model. It will just unpack the model and not the data sets and the other layers. This becomes, as you may imagine, this becomes critical when you are dealing with different life cycles. Like in eval time, you want the data set, but in inference time, you don't want that terabyte of data on your inference cluster. And when I run the kitpack command, it will do a very familiar thing. It will spit out something saying that, oh, I packed this layer, I packed this layer. In this case, it is saying they are already saved, because as you can imagine, I actually ran this demo before. It is saying that those layers already existed in my local machine, so it just didn't save it. It just referred to those bits on the manifest, essentially. So save some storage. And I'm going to push this to my registry. The registry, you can see that it says kind.cluster. It's actually running on my local host. I just did a DNS trick to map the local host. And now I'm going to use the Cosign to sign it. You may have seen this before. Let's verify it. Nothing, it's all working as expected, and that's actually the point. And now I'm going to do an attestation to it. Remember, we talked about the workflow, and there was one attestation side of it. The attestation that I'm going to add is something called scan results. Imagine that you are running a code injection scanner, like model scan or pickle scan. Where do you put that data? Today, for instance, Hugging Face does that for you. So does Jozu Hub. The difference is Hugging Face keeps that on Hugging Face side. Jozu Hub adds that as an attestation. When it is an attestation, the advantage of it, and we're going to look at it in the second scene, is you can actually make decisions by looking at that attestation, whether you want to move something to production or drop it at that point. So now attaching a file named scan results JSON as an attestation. So what this will do is it will package it, sign it, and push that to the registry. And when I download the attestation, I will be able to read the contents and also verify that it is coming from a valid signer. And then, does this work for skills? Can you package your skills to model kits? Of course you can. This is a typical skill. I don't even know what I have written here, so I hope it is good. But let's package it. The kit project has an init command that will basically create a kit file for you. I'll just do that. I'll just pass these, and here's my skill, the kit file for the skill. You may see that the descriptions are coming from somewhere. They are actually coming from the YAML front matter that was on the skill.md. So Kit basically just does most of the work for packaging the skills. And the rest is, as you may expect, package it, push it, sign it, and so on. So far, what we did is we did the production part of it. Like this is how you package your skill, how you package your model, how you package your MCP server, right? You package that into a model kit, sign it, attest it. If you have attestation scanning, provenance, we'll talk about it, data that you want to attach to it, you can actually put all of that to that single packet. And that package lives in your registry. So it travels with your model kit between registries, or registry 2 where you are running it. So now we're going to consume this package. Again, just for full disclosure, I have some environment variables which I am using so that we don't deal with a very long command line. Again, I'm going to do something different here. I'm going to package another model kit, but this time, as you may guess from the name, I'm not going to sign it. Another thing that I'm going to do after pushing is I'm going to also package the same model, essentially, to a model kit. But this time, as you can guess from the name, it's compromised, which means that I'm going to put an attestation that says it is compromised. So let's start with the compromised one. Let's sign it as well, so that it is real. It's coming from your build system. You signed it. It is correct. But then your pipeline kicks in, does a scanning, and discovers there's a code execution problem, or it scans your skill and discovers that there is a prompt injection in it. So remember, I talked about the attestation. This is the attestation that I have attached to the compromised model kit. One thing that you will notice, this looks very hard, but if you could see it, there is one line in there that says critical. And there is number 1 here. The attestation format we use at GitOps, and you can have your own, so this is in no way, I'm not saying that this is the standard way of doing it, but it basically says, oh, I found this, and it is critical. This is the number of items that I found that are in critical level. We kind of normalize the scanners into an attestation. And there is a explanation for it in the detail, saying that a suspicious pickle operation OS system invoked via -- radius. So next I'm going to put this attestation to the compromised image, compromised model kit. Verify that it is the correct one. I'm going to verify the unsigned one first, figure out that, oh, it's unsigned, so it's not safe for me to use. And now this is the interesting bit. Remember at the beginning I told you about, Cosign has this verify command that you can use. The verify command in Cosign can take a queue, like the same language that OPA uses for policies. So this is the policy that I'm using. As you can see, it's actually requiring the critical to be 0, high to be less than 5. So I'm going to just run the verify and do some JQ magic so that we can see what's happening with it. So it basically said pass. Did I verify the wrong thing? Yeah, I verified the correct one, which was the earlier one that we had. And now this is the compromised version. And it basically says, yep, it is failing for us. So this is, again, all of it is open source. Like Cosign is part of six-door. CNCF carries GitOps. OPA Q is part of OpenSSF now, I think. OPA is CNCF again. So this is all part of the open source ecosystem. And you can actually do this for your ML ops AI workflows today. There isn't anything that you need to wait, like open source way of doing this. Although the verification part is a little bit stitched together right now, but otherwise it's working pretty well. So the one part that I never liked about this is the verification and gating, because you are depending on Cosign verify command. It works fine, but it's not as easy as OPA or Querno. And OPA and Querno cannot do this because they are very specific to Kubernetes and they are very specific to containers. So the way that they work is they need to know essentially a resource, a Kubernetes resource, so that they can figure out where to get this from. And most of the time, AI/ML doesn't have that. And most of the time, you are actually running your skills on your laptop. So you need a different way of doing this. I am going to just show something that we have been working on. This is something we call the agent guard. It is essentially a micro VM that runs your agents, whether that is Cloud Code or OpenCloud or whatever your poison is. It can run them. But one of the big things that it does is it actually respects this secure supply chain. So I'm going to show that part. So in Agent Guard, we do have policies, and Agent Guard comes in with a policy engine embedded into it. When Agent Guard starts, it basically does signature checking, artifact and attestation checking as well. And one of the ways it does it is it has a policy language. And if you're familiar with the Kubernetes way of doing policies, this is Kubernetes, very close to the Kubernetes, how Kubernetes does policies natively. It is CEL language. We chose that because we could compile these policies at load time, and we wouldn't have any overhead at runtime. So this has some runtime advantages for us. Another thing that you can do with Agent Guard is you can add a policy for the host. If you're running it on your laptop, you can say that, hey, I don't want you to install anything from GitHub container registry. So, and now I had some agents that was prepared before. I'm not going to go into the details of that. The purpose of this demo is that you can see that this actually can work for any kind of environment. So I'm going to run an unsigned agent, which is a model kit, essentially. And I have a public key attached to it. So what Agent Guards, if it is still working, default behavior is to verify the signature if there's a public key attached to it. As you can see, because it's not signature, the verification fails. Agent Guard never starts. So let's look at an agent definition. This is what we are loading, essentially. And one of the things you will notice that there are modules in it. One of the modules at the end is called an untrusted MCP. And it is coming from a random registry. So I don't know that MCP, and I have a policy that says that registry cannot be trusted. So let's try to load that. Again, it goes through it. This time it is a signed model kit, so it has no problems with it. But then when it tries to verify the actual MCP, it doesn't like that it is coming from GHCR, and it cannot verify its signature. So it basically fails at that point. And finally, let's show that it can actually run. After failing so many times. So the rest is the same. This is pretty much how I use my coding agents nowadays. As you can see, it is in YOLO mode because I have host policies that are attached to it. The Agent Guard has guardrail and host tool policies. Tool policies limit what tools can do, including what kind of parameters can go into them. And the guardrail policies can either drop or redact what goes to the model itself. So you can actually drop things like secrets, privacy for data as well. With that, let's go back to our slides. We briefly mentioned that what happens with the provenance, right? It's like where does these things are coming from? And a good example of it is today when you go to Hugging Face, you don't know. Like there's 450,000 people on Hugging Face. And you cannot expect all of them to actually put signatures into what they are doing or have, they will not put, this is the data set I was using to train this model and that sort of information. So the best you can do today is you can, at the time that you are doing the import, the kit command has an import command which you can import models directly from Hugging Face. At the time of the import, you can actually put an attestation saying that I have imported this from Hugging Face, from this SHA, from this repo. So that kind of gives you a provenance data. But provenance is a very hard problem on AI ML because in normal Docker images, provenance is linear. You are always extending from Ubuntu latest or something. In AI ML, you are doing, let's say, you are doing training. There is a data set and there is a base model, right? Your fine-tuning basically is a tree of dependencies that you need to walk back to be able to verify the provenance. So you have a base model which is trained by certain data sets, which is created out of certain other data sets, for instance. So it becomes a tree that you need to walk to be able to prove the provenance. So the ML provenances are a little bit more harder to do, and there is no tool for it yet. And then I'm going to be honest with you. This is not easy. When you're doing scanning for 40 gigabyte data sets or 40 gigabyte models, storage is a problem because every time you're doing scanning, you're moving a 40 gigabyte piece into the scanner, doing the scanning, and then doing the attachment, discarding the storage. So it is a bit of a hassle. And then 40 gigabyte is nowadays not that big. There are larger data sets out there. The other problem that you always face, again, our experiment is our experiences, the experiments. Some organizations like to keep the checkpoints on experiments in model kits. That is a bad idea because there are so many experiments. So you need to be very selective about it because you don't want to promote every scratch build that you have done on software side, and then therefore, like, we're not pushing every PR to the model, to the registry. The same way, experiments works the same way. And we talked about the fine-tunes and the provenance chains as well. All right, so to wrap it up, when it comes to what we are trying to do is to get the ML ops and AI supply chains to the same workflow as software, which is sign, attest, and gate. And today, we do have enough projects and open source tools to accomplish that. And with that, yep. So it took us 10 years to do it for the containers. AI is faster. So hopefully, we're going to just do that in an hour. Thanks.